Welcome back to mathematics class. I'm your teacher, Mr. Kering, and today we are going to learn about integration. Today is on 22nd May 2020. So we say that we are going to continue with mathematics classes despite the COVID-19 challenge. That is a challenge to us. So we must continue learning, and this is the last topic of Form 4, that is integration. And in integration, we are going to learn 4 subtopics. One is reverse differentiation. Remember that we learned differentiation in the previous video. Differentiation. So we are going to learn about the reverse differentiation. 2 is on definite and indefinite integrals. 3, area under a curve. And number 4 is application in kinematics. So in form 2, we learned about equation of a straight line, and we say that y is in form of y equals to mx plus c, and we say this m is gradient. That is a gradient, and c is constant. C is constant. So we are going to consider this curve or this equation where we have y equals to 2x plus c. So for this case, the gradient of this equation is 2. Gradient is going to be 2. And we have also these parts where we have our gradient function equals to 2. This gradient function 2x. So this one must have come from equation y equals to x squared plus c. But this one must have come from this gradient function. You still remember in differentiation we said that when we want to differentiate this, we are going to take 2. We say 2, then we take x, then we say 2 minus 1 to get 2x. So this is where, as you can see, the 2 are going that way. And we were saying, so this is what we did in differentiation. So today we are in integration, and we are going to see on reverse differentiation. Reverse differentiation. So I want us to consider this example here, where we are supposed to find the function y if dy over dx is a 3x squared, b we have x cubed, c we have half x, then b we have 4x cubed. So we want to find functions of all this. So maybe we are going to do maybe 1 to 2 if we have enough time. We are going to continue with all of them. So this one is solution. In the first one, we have, this is the gradient function, meaning it is dy over dx equals to 3x squared. So now we want to find y. We want y is going to be 3x into 2 plus 1 all over 2 plus 1 plus c. This is how we are going to do it in integration. So we'll have 3x raised to power 3 all over 3, giving us x 3 plus c. So our y is going to be x power 3 plus c. So that one is the first one. The second one, we have, this is a. B, we have dy over dx equals to x power of 3, meaning our y is going to be x 3 plus 1 all over 3 plus 1 plus c, which is going to give us x power 4 all over 4 plus c. So our y is going to be 1 all over 4 x raised to 4 plus c. Then we continue to part C. Part C, where we have dy over dx equals to half x. So this one, we are going to have y equals to half x plus 1 all over 1 plus 1 plus c, giving us a half, not a half, 1 all over 4 x raised to 2 plus c. So, and what is the last, what is the answer of the last one? We are going to be able to have it here. D, we have 4x, dy, 4x cubed. So it is 4x cubed. So we have dy over dx equals to 4x cubed. So we'll have our y equals to 4x raised to 3 plus 1 all over 4 plus 1, not 4, it is 3 plus 1 plus c, which is our constant. So we are going to have 4 all over 4 x raised to 4 plus c, giving us as our y equals to x raised to 4 plus c. So all this we've used gradient function or the derivatives of all this to find the function where we have x, and you'll realize that this one is a reverse of differentiation. So in general, when we have our gradient function as dy over dx equals to x raised to n, then we are going to have our y as x into x minus or plus 1 all over n plus 1. So any number, you add 1, then you divide by the new n plus 1. So this is in general what we have as our formula. As long as n is not equivalent to -1. Okay, sorry. Here we have plus c. Always we have our constant that point. So it's going to be x raised to n plus 1 over n plus 1 plus c, which for this case is arbitrary constant, where we have n is not equivalent to -1 in this case. So we are going on to move to the examples. So we'll continue with this integrating. We want to integrate 2x. The first one is 2x raised to 5. The second one is x raised to negative 2. C is 5x cubed minus 2x plus 4. D is x raised to a third. E is going to be 3x raised to negative 2 plus 5x. So we are going to start with the first one, that is A. And we have dy over dx is given as 2x raised to 5. We say that when this is our derivative. So we want to find function. This one is our gradient function, so we are going to say y is going to be 2x raised to 5 plus 1 all over 5 plus 1 plus c, giving us 2x raised to 6 all over 6 plus c. This one is going to be, our y is going to be a third x raised to 6 plus c. So that is our function for the first one. B, we have x, we have our dy over dx given as x raised to negative 2. Then we have our y is going to be x raised to negative 2 plus 1 all over negative 2 plus 1 plus c. So we are going to have x raised to negative 1 all over negative 1 plus c. So we have this one as power of negative 1, meaning it's a denominator. So we'll have our y as negative 1 all over x plus c. So yes, so we'll also continue to maybe C, where we have our dy over dx equals to 5x over 3 minus 2x plus 4. So we have our y as 5x3 plus 1 all over 3 plus 1 minus 2x1 plus 1 all over 1 plus 1 plus 4 into x raised to 0 plus 1 over 0 plus 1. This one is 0 plus 1, then plus c, our constant c. So we'll have y equals to 5x raised to 4 all over 4 minus 2x raised to 2 all over 2 plus 4x plus c. So for this case we are going to have 5 over 4 x4 minus x squared plus 4x plus c. So that is our function. So I want to leave it to you as a student. Can you try to integrate this one and find the function? So let us continue with finding. We've talked about plus c. So we want to find the value of that c. So when you have this dy over dx equals to 2x plus 3, this is our gradient function, and we are told this to find the function of this gradient function, to find the value of y, and this curve passes through. It passes through point 0, 1. So this is where our line is going to pass. So we want to find the value of c. Of course, we know that when we want to find the value of y, we are going to say 2x raised to all over 2 plus 3x plus c. That is what we are going to get. So that we get y equals to x squared plus 3x plus c. But since we know the value of y here, so we are going to replace it. 1 equals to x, 1 equals to, we know the value of x here is 0 squared plus 3 into 0 plus c, meaning 1 equals to c. So we'll have a y equals to x squared plus 3x plus 1. And that is going to be our function finding the value of c. Next one, find v in terms of h. If we have our dv dh equals to 3 plus 4, an additional information is given that when v equals to 9, h equals to 1, h equals to 1. So these are additional information. We are told that to find v in terms of h. For this case, this one is finding y in terms of x. So we are going to say v equals to 3h raised to 3 all over 3 plus 4h plus c. And we know our v as 9 equals to, so before that one, we have to solve this one. H cubed plus 4h plus c will have, so we want to find value of c. We know v equals to 9 and h equals to 1. So this one is 9 and this one is 1 cubed plus 4 into 1 plus c. So we'll have 9 equals to 1 plus 4 plus c. So 5 equals to c. So we'll have v equals to h cubed plus 4h plus 5. So that is our how to find the value of c. So at this point we have the full function after finding the values of c, finding the value of arbitrary constants. So we will move to definite and indefinite integral. So in area approximation, there is one rule that we learned about using trapezium rule, and you remember that in this rule we were using trapezius, which we were making, so that we are going to find the trapezia rule. And you'll realize that there are some of, I'm going to just use this one to summarize what we did. You remember that there is this error that we talked about, that we say that it is going to be an area approximation. So when you want to find the area from this A to B, and below the area below this curve, the x-axis, and also between A and B, you realize that there's some error that we have to have because of this rule, trapezium rule. It is not actually accounting to every part below the curve. So, and we are going to use integration to find exact area of any curve. So we are going to assume, or we are going to take that we are going to make a small piece of this trapezius, as many as we can, in this area, so that here is going to be delta x, a small change in x, all the way from point 1 to point 2, so that we are going to have the sum of all these areas independently. Then we are going to add all of them to find summation x a to x equals to b, and we have expression of this function of y in respect to x. So, and for this case, we are going to use the integration terms, and these are going to be, we are going to integrate from a to b. We are going to integrate y in respect to x. So that is what we are going to find. So we can have one of the examples here. When we want to find definites. Now, definite means that they have the limits from a to b. Indefinite means there is no limit, so you are going just to integrate. But definite means it has defined limits. So we have this example here. From 2 to 6, we are supposed to integrate this gradient function in respect to dx. So we know that we have these answers: y equals to 2 into x power 3 all over 3 plus 3x plus c. So that is our part. So when x equals to 6 and when x equals to 2, so we are going to replace all of this. These are x equals to 2 and x equals to 6. So we are going to have this 2x3 all over 3 plus 3x plus c. And we are going to realize later that as we continue, we are going to ignore this c because the c is going to cancel out later. So from 2 to 6. So you can note where we are putting now. After finding the function, where we are going to put the limits is this side. So that we are going to take this one and replace with this one and subtract with this. So we are going to take values of 2, replace it here, and subtract them from when x is 6. So we are going to say it is going to be 2 into 6 cubed all over 3 plus 3 into 6 plus c less when 2 equals into 2 3 all over 3 plus 3 into 2 plus c. So you'll realize that the c's is going to cancel. It's going to cancel out. So we'll have our all this. When we work out, we are going to have 162 plus c as the first one. Then this one, we are going to get 34 all over 3 plus c. So that we have the c cancelling out. To have our answer as 150 and 2 square units. Remember that it was finding area of that region below the curve. So make sure that you calculate yours correctly there, so that you are going to have 150 and 2/3 square units. So we'll have another one. So as we continue, make sure that in the next questions, as we continue, we are going to ignore c, because at the end of the day, c is going to cancel. So let us consider this. We are going to integrate from 0 to 1 x raised to 4 minus 5 in respect to x. So we are going to have this. It's going to be x raised to 4 all over 5 minus 5x 0 to 1. So we are going to take the first one as 1 raised to 4 all over 5 minus 5 into 1 minus 0 raised to 4 all over 5 minus 5, 0. So for this case, we are going to have 1 all over 5 minus 1. All of this is going to be 0. So we are going to have 1 over 4 minus, so this one we are going to get negative 4 all over 5 minus 0, which is going to be negative 4 over 5. That is going to be our answer of that. Now this one is definite. This one is a definite where we have the limits. But we have another one where we don't have the limits. And this is going, we have this one, x squared plus 1 in respect to dx. So this one where we don't have limits, we're just going to have it as x raised to 3 all over 3 plus x plus c. So that one is going to be that way. Then we have another one where we have x3 plus 4x in respect to x. So we're going to have x raised to 4 all over 4 plus 2x squared, because when we have the 2, it's going to cancel out with this one to have to remain with 2 plus c. So that one is our answers. So we will now move to area under a curve. So area under a curve. This is where we have, maybe we are given that way, then we are told from A to B, bounded by x-axis, the curve, which is this one, and also A and B. Those are the limits. So we want to find the area of this. And in this, using integration, we are going to find exact. Like for this case, we have this one, y equals to half x squared plus 5, and it is between x equals to 1 and x equals to 5, and also the x-axis and x-axis. So this curve is bounded by all these curves. This curve, this function, x equals to 1, x equals to 5, and x-axis. So when we use trapezium rule, the answer that we are going to get in this case is 41 square units. So that is the answer that you will get if you are going to use trapezium rule. In fact, I want you as a student to try and see if you are going to get 41 using trapezium rule. We learned that one, and if you've not followed video, my previous video on area approximation, then I would advise you to follow that previous video. So we are going to use this one to find the exact number. So we are going to integrate this one. We are going to integrate from 1 to 5, and we have half x squared plus 5 in respect to x. So what we are going to get is this. We are going to have 1 all over 6 x cubed plus 5x to 1 and 5. So that we are going to have this one is 1. It is the same as x all over 6, which is going to give us 5 cubed all over 6 plus 5 into 5 minus this one is going to be 1 cubed all over 6 plus 5 into 1. So that we'll have all this. We are going to have this one is 25 times 3 is times 125 all over 6 plus 25 minus 1 all over 6 plus 5. So all this you are going to get 40 and 2 all over 3 square units. So this one, when you compare to this, you can see this one now is going to give you exact value, and this one is going to give you an approximation when you use trapezium rule. So you can see the difference is there's a slight difference, but this one is going to give you exact area under that curve. So we are going to continue with this one, finding areas under the curve. And we have this find exact area where we have find exact area under a curve. And this one is where we have y equals to x squared. Now this one is where we have the function and we have the limits x equals to 2 and x equals to 4. So, and remember that we said we are going to integrate from the limits y in respect to x. So for this case we are going to integrate from 2 to 4, where we have x squared in respect to x. So we are going to have x cubed all over 3 all the way from 2 to 4 to have this. So we are going to have 4 raised to 3 all over 3 minus 2 raised to 3 all over 3. And we are going to get, this one is 64 all over 3 minus 8 all over 3 to get, when the difference is going to be 64 divided over 8 is going to give you 56 all over 3 is the same as 18 and 2 all over 3 square units. That is the exact area of this function. Then again, we are going to move to this part where we have y equals to x cubed minus 3x squared plus 2x, bounded by this x equals to 1 and x equals to 2 and x-axis. So when we try to plot or to have a sketch of this, graph, we will have something like this. So, and the area that we want to find is from 1 to 2. Then we find out that it is that area below x-axis. So, and this one is where we have our function y equals to this. So we want to find the area, this area here. So, and what we are supposed to do is to find from 1 to 2, where we have x cubed minus 3x squared plus 2x, in respect to x, so that we are going to have x raised to 4 all over 4 minus x raised to 3 plus x squared from 1 to 2. So that we'll have this one, 2 raised to 4 all over 4 minus 2 raised to 3 plus 2 raised to 2 minus this one, 1 raised to 4 all over 4 minus 1 raised to 3 plus 1 raised to 2, so that we are going to have this 2 raised to 4 is going to be 8 raised to 2, it's going to be 16 all over 4 minus 8 plus 4 equals to not equals to minus 1 all over 4 minus 1 plus 1, so that here we have 4, I think here we have 0, here is 0 minus 0 minus a quarter, because this one also is cancelling out, minus a quarter, to have our answers 0 minus a quarter is going to give us negative a quarter. So since we don't have area as negative, we are going to ignore. And the reason why we have our answer as negative here, a quarter, it shows that the area of this curve is below the x-axis. So area below x-axis, you have to get it as negative, while this one is positive. So we are going to ignore, or we are going to discard the negative to have a quarter square units. So that one is going to be our answer. So make sure you remember that any area below x-axis is given as, you have to find as negative, and when you find that it is as negative, then you ignore and write your answer as a quarter square units. Don't just write negative a quarter square unit, that is going to be wrong. Just ignore this negative sign and have that one as so we'll proceed with another one. We have y equals to x squared minus 10x plus 9. So we want to find the exact area bounded by the curve y equals x squared minus 10x plus 9, and also x-axis and x equals to 4 and x equals to 10. So this, and when you plot this, when you have to have a rough sketch of this, you are going to find it that way. So from 4 here, we have 9 here, and we have 10 here. So this is the area that we are supposed to find. So that is our area we want to find. Another one is below and another one is above. So we are going to start it this way. We are going to find them separately. We are going to find this one from 4 to 9, then we find another one from 9 to 10. And remember that what we are going to get here is negative. So we are supposed to ignore first the negative so that we add this other one. So we'll have from 4 to 9, we differentiate x squared, we integrate 10x plus 9 in respect to d to the x plus from 9 to 10 x squared plus 10x plus 9 in respect to x also. So we are going to add the two. I'm going to add the two areas. So here is where what we are supposed to get. We are supposed to get x power 3 all over 3 minus 5x2 plus 9 from 4 to 9 plus x power 3 raised to 3 minus 5x plus 9 from 9 to 10. So we are going to have this one is going to be 9 raised to 3 all over 3 minus 5 into 9 squared plus 9 minus, where we have that as 4, we'll have 4 cubed all over 3 minus 5 into 4 plus 9. So this one is going to be 1, then plus, that is our plus this one. We will have this one as 10 power 3 all over 3 10 3 all over 3 minus 5 into 10 squared plus 9 minus 9 3 all over 3, this one, minus 5 into 9 squared plus 9. So all those, so that here we will have this one. We are going to get 9 all over, we're going to get here 243 minus 445 plus 9 minus 64 all over 3 minus remember that this one is squared, so we'll have here 80 plus 36 as the first one, plus this one is going to be 1000 all over 3 minus 500 here is 9x. Very sorry. Here is 9x. Sorry for this correction. We have here x and here x. So that here we will have 9 into 9, and also here times 9, another 9. We have here another 9, and we have here product of 9. So that here we are going to have 81. We are going to have 81. Then here we are going to have 80 minus that 6 is from where? So we are going to have this one. So here is going to be 9 to 9. Here is going to be 9 times 4. Here is going to be 10. 9 times 10, because this one is, the x is 10, then this one now is 9. So that here we are going to have the first one, which is this one. We are going to have 9, which is 81. This one we are going to have 36. Then this one here we are going to have 500 minus 500 plus 90 here minus this one, which is the same as this. This one also is the same as this because this is 9, 9. Meaning here we have 2, 4, 3 minus 4, 5 plus 81. So I hope you are not confused because of this error. So that we are going to have, in this case here, when you subtract here, we are going to get negative 81 minus negative, that one is here, negative 22, negative 22.66, all of this. Then you find the difference of that one, minus this one is negative 22. Then you plus this one. The answer of this is this. The answer of this is this one. Then we plus. We now come here to find the answer for this, which is negative 76.66 minus negative 81. So here we are going to have negative 58. We are going to have negative 58. When we turn this one, we'll have a third plus. And so this one, we are going to get it as 4 and a third. Because remember, this one is negative and negative. So this one is going to be greater than this one. So we'll have positive of 4 and a third. So what we are supposed to do here is to ignore the negative sign and remain with 58 and a third plus 4 and a third. So we are going to have 62 and 2/3 square units. So I hope I have not created a lot of confusion here. That error that we made earlier is this one. When we integrate this one, there is this x here. So that in every value of, for this case, in every value of 9, in limit of 9, we'll have 9 here. And also when we move to 4, we'll have 4 here. And in this part, where we have x here, we'll have 10. And when we have x again, we'll have 9 here to represent this one. So that when you work out all of this, remember to ignore the sign of this, because now the area of this one, the area of this is going to give you negative 58 and a third, while this one is going to give you area of 4 and a third square units. So you are going to ignore the negative. You ignore the negative so that when you add the 2 is going to give you, now the total is going to give you 62 and 2/3 square units. So that is the area bounded by the curve x equals to 4 and 10 and x-axis. So all those are the value or the exact area of this curve. So we'll move to the next one, where we have this one. So we have this one where we have y equals to 9x minus x squared and line y equals to x. So when we have the 2, we are going to have this one all the way to 9 from 0. Then we have this line where y equals to x, and this one is y equals to 9x minus x squared. So we want to find this area. That area bounded by the two functions. That is 9x minus x squared and the line y equals to x. So what you know here is that we are going to take the area bounded by the line and x-axis subtracted from the line bounded by the curve and the x-axis. Meaning that we are going to say, or before, or maybe just say 9x minus x squared dx minus this one is x to x. So we are going to have this one. We are going to say 9x minus x squared equals to x equals to x, and what we are supposed to do here is to have it this way. We are going to remain with 8x minus x squared equals to 0, so that when we factor out x, we will have 8 minus x equals to 0, meaning we will have x, this one is x equals to 0 and x equals to 8. So our limits that we are going to use here is from 0 to 8. From 0 to when x is 8. So we are going to have this as our, so we'll have this one, the y, this other one. When we integrate this one, we will have 9x squared over 2 minus x cubed all over 3 from 0 to 8. Then we less, we'll have this one as x squared all over 2 from 0 to 8. That is what we are supposed to get. So that when we proceed, we are going to have we are going to say 9 into 8 squared all over 2 minus 8 cubed all over 3 minus, this one when we replace it to 0 is going to be 0, but for the sake of just doing, I will have 9 0 squared all over 2 minus 0 raised to 3 all over 3. Then we less this one, which is going to be we are going to replace it with 8 squared all over 2 minus 0 squared all over 2. So what we are supposed to get here is that we are going to get from this point, we are going to get this one is 288 minus 64 all over, not 64, we're going to get 170 and a third from this, so that we get here. Then this one is going to be 0 minus, which is this one, where we are going to get, this one is going to be 64 divided by 2, is going to be 32 minus 0, which is this one, to get 117 a third, this one, minus 32, and the answer is going to be 85 a third square units. So that is what we are supposed to guess. So as you can see, we are going to find the difference between the two. The smaller one subtract from the bigger one, and the limits are from 0 to 8 because of this, the difference between the two. So here is where we are accurate. This equation is the same as this one. This function is the same as this one, this point of intersection. So that is how you're supposed to have your answers as that one. So I want to give you maybe one. Find area bounded by the curve y equals to x squared minus 7x and y equals to x, the same as that one. That is A. B is find the area, exact area bounded by the curve y equals to x squared minus 5x plus 6, and these limits. So that is your assignment for today on area and curve. So we want to complete by application in kinematics, and in chapter 8 we talked about when you differentiate displacement in respect to time, what we get is velocity. We say ds over dt equals to velocity, while dv over dt is acceleration. So for this case, I want us to reverse, where we want to find a displacement. We are supposed to integrate velocity, and when we are supposed to get velocity, we are going to integrate acceleration. So here we have when we want to find, we are going to integrate velocity in respect to time to get displacement, and also we are going to integrate acceleration in respect to time to get velocity. So we have an example here. Velocity of 4 minus t meters per second. Find the expression of displacement of s given that we are supposed to find expression of s, which is the displacement when s equals to 4, t equals to 0. So So I want us to integrate this velocity, where we are going to say we are going to integrate this one 4 minus t in respect to time, so that what we are going to get here is s equals to, because when we integrate velocity we get displacement, we are going to get 4t, we are going to get 4t minus t squared all over 2 plus c. So at this point we want to get c, because we have when s equals to 4, t equals to 0. So all of this is going to be 0, 0, 0 squared all over 2 plus c. So 0, 0, meaning our c is going to be 4, and our answer is going to be s equals to 4t minus t squared all over 2 plus 4. That is our expression of displacement. This is one. Number two is that we want to there is a velocity of a particle is 4 meters. Velocity of a particle is 4 meters per second. When displacement is 5 meters, t equals 2 seconds. Now, find expression of s in terms of time. Find expression of s in terms of time. So what we are supposed to do here is so we said the first one is find expression of s in terms of t, that is A. Find expression of s, which is displacement. B is find the distance during the 5th second. BA is find distance during the 5th second. B2 is find distance between time equals to 1 second and time equals to 3 seconds. So we are going to start with the first one, find expression of s, and what you know about that is that we are going to integrate v in terms of time, and our v is 4, so we are going to integrate 4 in respect to time, and we are going to get 4t plus c. So that is our s is going to be 4t plus c. So we are given our s is 5 meters, so 5 equals to 4 when t equals to 2 plus c. So our c is going to be 5 minus 8 equals to c. So our c is going to be -3. So our s expression is going to be s equals to 4t minus 3. So that is going to be our expression. Then we move to distance during the 5th. Distance during the 5th second. So we are going to integrate this one. The 5th second is from 4 to 5th. So 4t minus 3. We are going to integrate that one. We are not going to integrate, these are the limits, we have already integrated. So we have this one from 4 5, so that we'll have 4 into 5 minus 3 minus 4 into 4 minus 3, to have, here we have 20, we have 17, minus 16, minus 3, we have 13. Yes, to get 17 minus, we have 4. So this one is going to be 4 meters because it is distance. We are going to get 4 meters. Then we move to this other one. The distance between t time equals to 1 and time equals to 3. So we'll have this one is going to be 4t minus 3 in distance from 1 to 3. So we are going to have 4 into 3 minus 3. Then we have minus 4 into 1 minus 3. So here is going to be 12 minus 3, and here is minus 4 minus 3. So here we have 9 minus 1. It's going to give us 8 meters. So that is how to apply when it comes to kinematics. And I want to give you one question here to summarize with it. These are the questions. When velocity is given is 20 meters per second, acceleration is given as 5 minus 3t. Find its velocity when time. Find velocity when time equals to 3, and also find the distance. B is find the distance when the particle comes to rest. Find the distance when the particle comes to rest. So that is your question, which I want you to spend your time. The question is, a particle moving in a straight line starts at a fixed point O with the velocity 20 meters per second. After t seconds, its acceleration in meters per second square is given by 5 minus 3t. That one. Find A, its velocity at time equals to 3, and B, the distance covered when the particle first comes to rest. So that one is on about integration. We are through now with the syllabus of Form 4. The next videos that I'm going to post, or as from tomorrow, is a revision of all these parts we've been learning, and I appreciate some of you are sending me very interesting questions. I've managed some I'm still doing. Then I'm going to send all of them before the end of the day. So continue learning. Remember that this pandemic is going to be over. We don't have to worry much. Make sure you wear your mask, you sanitize, you keep distance, and this coronavirus is going to be over. Have a good night, enjoy your time, and thank you once again for learning mathematics.